Good day, everyone. My name is Isaac Wong. I'm a tech support engineer from SuperGeo GIS Technical Support and Training Center. Today, our topic is Introduction to GIS. And this is the agenda today. In the beginning, I will have a brief description to GIS. Then, I will explain some basic concepts about GIS, including GIS data, its coordinate, and scale. After that, I will also introduce some simple operation with GIS software. And at last, I will show out what we can do with GIS software in real world. So, what is GIS actually? In its simple definition, GIS is a computer system that can be used to storage, view, analysis, manage, and integrate geographic information. It can help us to understand the relationship between maps, patterns, and trends. It also allows us to process and query large quantity of geographic information within a single database. In fact, the application of GIS now are widely used in almost everywhere, like decision making, data management and integration, or even disaster control. Besides, GIS has been applied to assist experts or professionals in analyzing various types of data and dealing with complex situations. Therefore, GIS now plays a very important role in this generation. For example, there are many kinds of chain stores around the world, such as coffee shops, convenience store, drugstore, and so on. In fact, it is not difficult to have a store, but to find a suitable location could be a huge challenge. Since if a store runs in the right location, it will help to increase your sales amount. On the other hand, if choosing to a wrong location, it will also become a tough business. However, to investigate a suitable location for a store might take a lot of time and money before. But now, the technology of GIS can easily solve this problem. In this case, we can apply GIS tool to overlay the different features for analysis, like the data of population, transportation, potential customers, or even the store distribution map of the area. Then, we can choose for the most suitable location for the store. Therefore, by its economy and strategic value, GIS now is getting big awareness and growing interesting to everyone. And in next part, I will start to explain some basic concepts to GIS. So, let's move on. GIS data includes both spatial and attribute data. Spatial data is just like trying to tell us where the target is. It shows the relationship between location and shape of geographic features. On the other hand, attribute data is just like to tell us about what target is. It usually consists by several columns which represent to the different geographic features. And this is an example of spatial data. On the left-hand side is a map which including Africa and part of Asia and part of Australia. Then we use magnify tool zoom into the range around Taiwan. So the map on the right-hand side is the largest scale map. And if we try to find where Taiwan is, from this map, the spatial information can easily tell us the nearby geographic information to Taiwan. And it is on the south side of Korea and next to China. Therefore, spatial information can easily provide us the relative location from geographic data. And more, SuperGIS also provide a precise location information using the coordinate system. And about the attribute information. In GIS, each feature has its related attribute data. And each set of attributes has record in attribute tables of a layer. And here is an example of attribute data. The fifth column lists the number of each records, and each rows represent one set of attributes. And each column is a category of attributes. Like where I mark Taiwan on the attribute table here, it is easy to see the short name, population, and economy of Taiwan by the attribute table. So, by attribute data, we can realize the information with any feature more efficiently. However, there are two types of data model in spatial information: vector data and raster data. The raster data include point, line, and polygon. And about raster data, it is consists by equally sized cells arranged in rows and columns, and each cell contains attribute and location information inside. And next, we will have a brief description for both of them. And to vector data, like we mentioned before, its geometry type are point, line, and polygons. And we must notice that the geometry type of feature in a single layer must be consistent. And in the example here, we use the point represent to the bench, and the line feature represent to the river, and the polygon feature to represent to the grass area. And by overlay different kind of vector data into a layer, we will have a completely geographic system. And then we will have a brief explanation to each kind of vector data. And first one is point feature. Like the example here, a point is defined by a pair of coordinate x and y, and one or more points consists a point layer. However, although we can adjust the size of symbol to the point, it still doesn't have any length and area information inside. And to a line feature, at least 2 points consist a line, and the line features contain the length information but no area information inside. And from the diagram here, to the line feature, the point represents to the beginning and ending point called node, and the xy coordinate pair that define the segment for the line features called vertex. And last one we want to talk about is polygon features. From the diagram here, polygons is defined by a connecting of line, and it is a closed shape feature which the first and the last coordinate pair are the same. And to polygon layers, it contains the length and area information inside. So now let's start to talk about the raster data. Raster data are consist by a grid of cells, and each cell in feature store a value, which includes the location and the attribute information. For example here, this is a DEN data map. It means it consists by the cell that each of them contain the elevation information. And from the color bar here, we can easily realize the deep blue area here represent to the highest attribute area. Then, in next part, we will start to introduce about GIS data format. To GIS data format, based on we have vector data, raster data, paper metadata, even static data. And here we list some data formats here. And from the list here, we realize each kind of data might collect or preserve by different format. Therefore, here I choose two GIS data formats as an example today. First, I'd like to introduce GeoFile data. Among all these file formats, GeoFile is the specialist which developed by SuperGeo. It is also a SuperGIS internal data format. And here I put an example to GeoFile, and it comprises two files, GEO file and DBF file. and the attribute table of GeoFile is stored in DBF file format. And another example we like to use is shapefile. And about shapefile, it is the most commercial and published GIS software format. And it also comprised by the SHP file, DBF file, and SHX file. And just like GeoFile, the attribute table in shapefile is also stored in DBF file. And next, we start to introduce about the coordinate system. Coordinate system is an important information to GIS software, since different data resources may contain different coordinate systems. In this case, choosing to the right coordinate system for the layer is very important. And coordinate system is classified into geographic coordinate system, for example, the WGS 1984 and ITRS 2008, and the projected coordinate system like UTM and transverse Mercator. Then next, we will have a brief description to them. In geographic coordinate system, any location on Earth can be defined by longitude and latitude. For example here, we can use longitude and latitude to locate the center of earthquake or the location of typhoon. And in geographic coordinate system, the Greenwich, England was established the position of 0° longitude, and the equator has a 0° latitude here. And this is the illustration to the geographic coordinate system. And from the illustration here, we can easily see the 0° longitude and latitude here. And the North Pole and the South Pole are 90° in south and north, respectively. And also, in geographic coordinate system, the equator divides the globe into the northern and southern hemisphere. And about the project coordinate system, it is expressed the location on 3 dimensions by 2-dimensional surface, cylinder, or cone, and then unfold into a map. But this procedure may cause distortion in shape, area, distance, even direction to the data. So, some of you might be curious, if coordinate transfer might cause distortion to data, why should we still do projection? However, although many mapping applications to the Earth can be assumed to be a perfect sphere, but there is still have some variance in different areas. Therefore, in different countries, many projections have been developed and used for more accurate measurement. Besides, most maps right now are recorded by 2-dimensional map form, and after projecting, meter can be also the universe unit. So, both of them will be a great help on store and calculate to map. And this is the Earth, which displayed by 2 different coordinate systems. In the left-hand side is the geographic coordinate system with 3 dimensions. And in the right-hand side is the result of a flat 2-dimension platform which projected from 3 dimensions. And from the illustration here, we can easily see the difference between the geographic coordinate system and the projected coordinate system. And after the coordinate system, let's talk about scale. Scale in GIS means the ratio between the feature size in map and its real size of the world. And it also decides the area that display to the view extent. And it can be changed by setting different scale. And for the example here, in scale 100 million map years, it covers America, Africa, and Asia. But in scale of 100 million map, we can only see part of Africa. So in this case, we realize larger scale we have and more explicit map we can see. And next, we will have a short video for introduce the basic operation to GIS software. Since we already have a basic conception to GIS, now we start to introduce some simple operation by GIS software, SuperGIS. And this is the interface of SuperGIS, including the map menu, common use toolbar, map windows, and table of data contents. In addition, SuperGIS also provides a map coordinate for precise location information here. And to start with SuperGIS, now we can see there has already a point layer in the map windows. And if we want to add more layer into the map windows, we can just right-click to the layer in the data contents here, and there will be a function add layer. And we click the option here. Then we can see the window that allow us to choose the layer we like to join. And here we choose the demo 2, the line layer, to join the map, and press open. Then the line layer has joined into the map window. On the other hand, we can also add layer directly by the add layer icons in toolbar here. Then we click the icon, and it also shows the window to select the add layer. And here we choose the polygon layers with the demo 3, and also press open. Then we can see the polygon layers demo 3 had joined into the map window. Besides, we can also change the color to the features. And to change the color to the features, here I use the polygon as an example here. To change the color to the polygon layers, we just need to double click to the symbol of the polygon layer. And then the symbol select window will show up like this. Then you can see here we can change the color of a feature in this window. And here I choose the color to change and press OK. Then the color of polygon had been changed. In addition, we can also change the symbol type to the features. And here I use the point layer as an example here. And to change the type of symbol, just like to change the color, we just double click to the symbol to the point layer. Then the symbol select window will also show up. And then we can choose the symbol type here. And we can see now the point feature is the circle shape. And we select to change point layer into the diamond shape, and also change the color maybe, and also setting for the size of symbol. Then we press OK. And then you can see all the point layer has been changed into the green and diamond shape. More, we can also change the background color and type to the map windows. And to change the color and the type in map windows, we just need right-click on any location in map window. Then we can see the last operation property. And under the General tab, we can see the background option. Then we click the option here. And the symbol select window also show up. And we can change the color to the map here. Then we press OK, and the background color is changed. To more operation, we can also turn off and turn on the layer by selecting here. And for the example, turn off, turn on. And to polygons, turn off and turn on. And if you need a more explicit map, we can also use the zoom in tool here. And we click for the zoom in tool and select for the area we want to magnify. Click, click, click again. And we can see this function will enlarge the area we select. And also we could try the zoom out tool here. And we press the tool, and we also click to the area, click, and click again. And from this operation, we will see this operation will minimize the area. And in addition, we can add the label to the features. And how to add a label to the features? We could just right-click to the layer which you like to join the label. And you will see the option label features here, and click the option. Then we can see the label has attached on the polygon features. And more, we can use the pen tool to move the locate of the features. And the pen tool is right here. And to use the pen tool, we just hold click and pull. Like this, hold click and pull. Then we can keep pull to move the location to the features. And if we pass through the destination you want, you can also use the back extend icon on the common use toolbar and here to back to the last step. Let's try once. Back, back, and back again. And what if you want to cancel for the label? And it is also very easy. We just do the procedure before again. Just right click to the polygon layers and choose the label feature here. And you can see the label has been cancelled. And SuperGIS also provides the function which allows to make full extend to the all layers. And here it is the function here. Then we click the icon for extend, and the map window will change into a full extend situation. And more, if you want to select the features, you can just click the select icon here, and you could click any feature you want, no matter polygons, point, or line. And if you want to select more than one feature in the same time, you can just press Shift on the keyboard, and you can choose one symbol and more symbol in the same time. And what if you want to cancel all the selection here? You could also use the icon, click selection, just right here. Then we'll press the icon, and all the selection will be cancelled. And to understand the information to the features, we can open its attribute table. And to open the attribute table, we could just right click to the layer you need, and there will be an open table option. Then we click this option. And here it is the attribute table to a layer. And we can see the information to the features. And just like in this table, it includes the server aid and other information inside. And then we select a feature data. And you can see the relevant feature on map window will be marked right here. And on contrary, when we select the feature in map windows, the relevant attribute data in the attribute table will also be marked. It is very funny, right? And on the other hand, we can also use Identify tool here to realize the information to the feature. And after we click the Identify tool here, we can just click the feature directly. Then you can see the Identify window will show up, and you can easily see the attribute information to these features. And in Identify window, we can also add the hyperlink here. And to add a hyperlink, we could just right-click to the feature name here, and you will see the Add Hyperlink option. And we click this, and here we can see in the window, we could join the URL or choose to the file root here. And here we use the website of SuperGeo as an example here. Then we paste the website to the URL and we press OK. Then we click the hyperlink icon on the toolbar. And you can see the feature which be set to the hyperlink will be marked just right here. And after we click to the feature, it will lead us to the SuperGeo immediately. And above is the simple operation to GIS. And let's move to next part. And after show video for the basic operation to GIS software, let's start to talk about data process and data analysis. However, spatial data in GIS are displayed in point, line, and polygons. And different types of features are saved in different layers. So, if we want to intersect layer A and layer B or clip a line layers onto another layers, then we can apply the geoprocessing tool in SuperGIS to deal with spatial data. And these operations can satisfy our demand, also static and analysis to the spatial data. And in SuperGIS desktop, there are 5 operations in geoprocessing tool, including dissolve, merge, clip, intersect, and union. And the functions and operations of 5 tools will introduce in the following pages. First operation we introduce is dissolve. Dissolve means we create a new layer by merging polygons that have the same attribute and also remove the boundary of the polygons. And it is also the only operation which can be performed on one layer, since other geoprocessing tools are all involve 2-layer operation. And the diagram here is the example of dissolve. We like to dissolve the field geologic to the original polygon on the left-hand side. And after dissolve, like the diagram on the right, we will have a new polygon and a new row in attribute table which made by dissolve according to its feature. And this is the screenshot for geoprocessing tool of dissolve. We choose the dissolve target layer for the input layer, and then also choose the field value for dissolving field. And after confirm the path for saving output layer, click OK. Then the setting of operation is done. And after geoprocessing tool process is finished, the output layer will be added as a topic layer to the table of data contents. However, dissolve summarizes the field value for the dissolve features, and it is also provide a static function like maxima and minima. And if the field for dissolve is geologic data field, the feature with the same geologic data will dissolve as one feature. Therefore, some of the boundaries of the features might change by this operation. And next, let's turn to the next operation, merge. Merge is to combine 2 layers into 1 layer, and so does its attribute table. It will also be combined into 1 attribute table. However, it can only be performed on same geometric type, such as point-to-point, line-to-line, and polygon-to-polygon features. And like the example here, we use the layer point-to-point. And in this example, we merge 2 point layer into the same layer by geoprocessing tool merge. And the diagram at the right is the result layer after merge. And this is the screenshot for geoprocessing tool of merge. We choose the first layer for the merge as input layer, and then choose the second merge layer for the operation layer. And after confirm the path for saving the output layer, then click OK. And after merge, the attribute table will contain the attribute data from both layers, but still based on the attribute table of input layer. And to be noticed, like we mentioned before, when you select a layer for input layer, the operation layer drop-down list will show the same type layer only to prevent you from choosing other type of layer which cannot be merged with. And next one, we start to describe about clip. Clip is to cut a feature with the polygon layers and to extract the feature from the input layer. Therefore, to implement clip operation, the input layer can be any geometry type of the layer. But to operation layers, it must be a polygon layer. And in the example here, we try to create a new layer by extract a river within the area. And we can easily achieve this purpose by geoprocessing tool of clip for operation here. And this is the screenshot for geoprocessing tool of clip. Like the example in last page, we like to extract a feature within a polygon. So here we use the tool clip for operation and then select the feature for input layer. And also we choose the polygon for the operation layer. And after checking the path for saving output layer, click OK. Then the setting of geoprocessing tool of clip is done. And next, we will talk about intersect. The geoprocessing tool intersect compute the geometric intersection of two layers, and then create a new layer only containing the feature in the common area. And the feature table of the new layer will list the data of two layers. However, intersection layer must be performed on polygon layers. And for the example here, we overlay two original layers and capture all the area that both of them covered. And then, see the diagram in the right, it will create a new layer for saving the result from the intersect. And this is the screenshot for geoprocessing tool of intersect. We select the polygon layer for input layer and select an intersect layer for the operation layer. And after checking for the path to saving the output layers, click OK, and the setting of operation is done. And let's move to the last operation, union. Union is to combine both layers into a new layer, which is unite the area from both layers and also contain the attribute data from the original layers. The figures here shows two original layers before union, and then the new layer created by union. It displays the result which overlay two layers and capture all the cover area from both of them. Besides, the attribute table is also the union of attribute of the two layers. And the field in the new attribute table includes the field from input layer and from the operation layer. However, union can be only performed on polygon to polygon layer. And this is the screenshot for geoprocessing tool of union. And the input layer and the operation layer here, we choose two layers to be united. And at last, checking for the path for saving the output, then click OK. And the setting of the geoprocessing tool of union is done. So, after data processing, let's talk about the data analysis. First, I'd like to introduce overlay analysis. Since every layer may represent their features, we can analyze the information by overlay the features from different layers to the same area. Besides, based on integrate two or more layers into a common coordinate system, we can easily manage and analyze the relationship between features which locate in the same geographic data. On the other hand, buffer analysis is also a very important function. Buffer analysis is an area surrounded to the point, line, or polygon features at a specific distance. Therefore, buffering is often used for nearby information analysis. For example, if we are investigating an area, we can apply buffer to find a river basin which is near the forest within 100 inches. And in SuperGIS, we can also choose the buffer all the features or just only buffer for select features. However, choosing different target layer to store the buffer feature will cause different buffer effect. And this is the example shows choosing different target layer to store the buffer features. To the point layers, there will be the circle zone from the point features. And to the line or polygon layers, there will have the ribbon shape around the features. And during the brief description to data process and data analysis, let's move to data query and data selection. In GIS software, data query and selection is a very important part. And to data query, we have query by spatial data and query by attribute data. And to the data selection, we have selection by attribute and selection by features. And in next few pages, I will introduce them one by one. First, we introduce query by spatial data. When viewing the map, users can view the related attribute of the feature by Identify tool directly. And after we find and click Identify tool, which is in the common use toolbar, we can just click to choose the feature that you want to identify. And then the Identify window will show up with the attribute information to the select features data immediately. And to select different layers of features, the window will show the identified features and their layers. And like the upper identify windows here, when you click the different feature in the upper panel, the attributes in the downward attribute window will also be changed immediately. However, if you are looking for any feature in some keywords, you could apply the function find. It will help you to list every feature which contains the keywords inside. Like the example here, we have a map and we are looking for any information to adjust. So we just use the function find and input the keywords adjust. Then we could select the search layer and its search field. Then press go, and the result will show at the window beneath. And in addition, from the diagram on the right, we can also click any search result in the search result window for mark the feature on the map. However, in the attribute table, there is also a function called find and replace. You can also use this to find some keywords in a specific field, and also it can replace the found item into a new input words. And this function is under the button option from the attribute table. And just like the function find we mentioned before, the data matching the keywords which we input will be found. And more, if you click replace, the found item which you mark will be replaced with the input data. And if we click replace all, then all found items will be replaced. However, under the attribute table, we can also click any feature inside for mark the feature onto the map. And different from the query, we can also make a selection here by using the function select by attribute. Like the window on the left, we could select the feature by setting the attribute table. And we choose the select there and the select mode. Then we create the SQL expression by click the field we need. And like to click the value in the field and also click for choosing the operator, and after that we click Query, and the record that matching the expression will be displayed and also marked in the map windows. And in addition, like we mark here, we can also see the select static result here from the attribute table. On the other hand, while viewing the map, SuperGIS Desktop also provides several feature selection tools to view and select features. And the feature selection tool includes select features, which in the common use toolbar, and select by features. And to the icon select feature function, we can easily find the button in tool menu, and after we click the button, we can just click the feature by click the feature on the map directly. Besides, you can also press Shift key to click more than one feature in the same time. And if we want to select the feature by compare with other layers, we can use the function Select by Feature. Select by Feature is in the main menu and under the button of selection. And in this operation, in its operation window, you can select the layer you would like to query and set the selection mode. Also, you can select the field and the operation between two layers. Then, results that satisfy your expression will mark in map windows. And in this example here, we want to select the river that across this area, so we just choose to the state there and select intersect to the feature of river. And after press apply, the river within this area will be selected. And next, we start to talk about GIS display. To a common vector layer, it includes different data model type, and the feature symbol also contains different type of layer. So, by setting layer symbology, it can be displayed more various and clearly mapped by classification to the information of the layer. And generally speaking, the default symbology adopts single symbol. But how could we to set the layer symbology? Actually, it is easy. Just right-click to the layer and choose Properties. And under the Layer Property windows, with the Symbology tab, there will have several symbology you can use. And we could choose the symbology type according to the information of the layer. And in this PowerPoint, we choose 4 kinds of symbology for display here. First one is unique symbol. Like the example here, unique symbol is display the different attribute or attribute combination of multiple fields with different symbol and colors. It can make the maps to be easier defined with the difference of area. And in the example here, we use unique symbol for discriminate the different districts in this area by color. And another symbology is graduate symbol. To graduate symbol, it classifies the quantity data and display the attribute with different size of feature. And in the example here, it shows the population map by graduate symbol. And in this map, the larger symbol it has represents more population it has in this area. In addition, dot map is also a symbology which displays the quantity value of the features. But different from the graduate symbol, dot map displays the quantity value with distribution of dots. And same as previous example, this is also a population map to the area. But in this time, we use dot map for represent the map. And in this map, one dot represents 2.3 million people. And from the dot map, we can easily know the quantity by reading the distribution of the dots. However, if you want to display the multi-field in the same time, you can also adopt static map for display to the multi-field for the layer with bar chart. It can read the data of different fields at the same time and also allow us to compare with them. And for the example here, we can easily compare the relationship between GDP and population by bar chart in each district here. Then, let's talk about export. Sometimes the layer data may be too big, but you only need part of it. In this moment, you can choose to output the feature from layer by the function export. To export the GIS data, here we have export to features and export to layer. In SuperGIS Desktop, if you just need export the feature without any other information, you can choose to export to feature. And SuperGIS also provides to export the feature in the view extent or just export to the select features. However, to be noticed that the export result from a function export to feature doesn't have any symbology information inside. In addition, we also have another method to export. After the map is edited completely, all of the layer can be exported to the function export to the layer, and it will preserve all the settings in the moment. And when the next time you import the layer which exported it, the adding information will display with the same setting now. So, once we have finished a map, we can switch to the layout view and make it represent as a layout view. And beside the map, the element of layout map includes the scale bar, compass, title, and legend. And each element is provided in different type for user to edit and apply. And on the other hand, after we change into a layout view, the layout toolbar will automatically add here. It can help us to design a map easier. In addition, SuperGIS Desktop also provides a function to change layout template. This function is for the users who want to define their own layout template, and by this function, they can design a custom template as they require. However, after you finish a project, you could share your project of geographic information over the internet. And for supporting desktop, mobile, and web application, our product SuperGIS Server can help users to share the GIS resource across the web. And it also allows users to share the geographic information for the people around the world. And about the SuperGIS Server, we will have another chapter for a more explicit introduction. And this is the lesson today. Thank you very much.